number system, and specifically, we're going to use rational numbers. We're going to take rational numbers like decimals and turn them into fractions. Okay? We're going to tell which is greater and which is less than a fraction or a decimal. So that means we're going to turn our fractions into decimals using the calculator. All right? So up on the board, we have the real number system. Okay? In the real number system, we have rational numbers and irrational numbers. Okay? If it's a rational number, it has a chance to be an integer. And if it's an integer, it has a chance to be a whole number. Now, we've already covered the definitions of each of those. So if you've forgotten, you can turn to page 224, and they'll remind you what each of those definitions are. Definitions that you need to know when it comes to rational numbers. The first one is terminating decimal. If you've ever seen the Terminator, he terminates. Okay, he stops people, right? Okay. Well, a terminating decimal is a decimal that stops or ends. A terminating decimal terminates. A repeating decimal is a decimal that goes on forever. It repeats again and again and again. In bar notation, for example, we have 0.23 with a bar over the 2 and the 3. That means you repeat the 2 and the 3 over and over, forever. Here we've got a 0.23 with a bar only over the 3. That means you repeat the 3 only. So you write the 2 and the 3 and then just keep writing 3, 3, 3. That's bar notation. Alright, on the board we have two different examples. We got a decimal that terminates, and we have a decimal that repeats. Alright? Now your instructions on both these decimals are to turn both decimals into fractions. Your instructions are to turn both decimals into fractions. Okay? Now I want you to see the rule. You always choose the first two places after the decimal and write them down. Take the 2 places after the decimal and write them down. Now put you a divide line to make it a fraction. Now the only difference in the two is what do you put on the bottom. Okay? If it's a terminating decimal, you put 100 on the bottom. Terminating decimal, you put 100 on the bottom. If it's a repeating decimal, you put 99 on the bottom. Now, I have turned both of these decimals into fractions. Now, the next part of your lesson is going to say reduce. Well, I can't reduce either of these because 23 is prime. Okay? So there's your answer. 0.23 as a fraction is 23 over 100. 0.23 with a bar over it is 23 over 99.
Yes, sir. All of them with a bar, no matter what.
Now, we have an example, 0.6. And the instructions say express the decimal as a fraction or mixed number, and it should say in simplest form. Now, 0.6, 2 places after the decimal, what would I put? 60, because we know it's 0.6000, but we just don't write that. So we're going to choose 2 places after the decimal, which is 60, and put it over 100. Now the reason we're doing this is we want to make this decimal 0.6 into a fraction. Now, anytime you have 2 zeros on the end in a fraction, you can cancel them out. And that just leaves you 6 over 10. But now 6 over 10 is not what? Reduced. Now, I have showed you to reduce a fraction. You find the factor tree of 6, which is 2 times 3, and the factor tree of 10, which is 2 times 5. So now you know 6 was 2 times 3, which is what I have right here, 2 times 3. And you know 10 was 2 times 5. Now on the top and bottom, you have a 2, so it cancels. So your simplified version is 3 over 5. So the fraction 0.6, the decimal 0.6 as a fraction is 3 divided by 5. In this example, we have a repeating decimal. The decimal is 0.444, and it repeats forever. Okay? I've told you to take 2 places after the decimal, and since this repeats, I put it over 99. Now, into 44 goes 2 times 2 times 11. Alright? And into 99 goes 3 times 3 times 11. Now they both have an 11, so it cancels. And the simplified version of 44 over 99 is 4 over 9. 2 times 2 is 4. 3 times 3 is 9. Okay? This is the simplified version of the repeating decimal 0.444. Now our last example is the negative 0.151515. Now, you write the negative, and then you take 2 places after the decimal. So I got negative 15 over what? 99. It's 99 because it repeats. Okay. Now you've got to reduce negative 15 and over 99. So into 15, what goes into 15?
3 times 5.
3 times 5. And what goes into 99?
3 times 3 times 11.
Yeah, it's 9 times 11, and 9 is 3 times 3. So I've got 15 is 3 times 5. And 99 is 3 times 3 times 11. So now my 3's cancel, and I have 5 divided by 33, but now 5 is going to be negative. Alright, the middle part of your homework is going to say, tell what set this number belongs to. Okay, that means, is it real, rational, whole, integer? It wants to know which of those it is. Well, all of them are real that we're messing with today. And this one is rational, because all fractions are rational. Okay? Now, is this whole or integer?
No.
Is this an integer?
No.
No, because it's a fraction. And no fractions are integers unless they reduce. For example, 9 divided by 1 equals 9, which is an integer and a whole number. But this does not reduce. Therefore, all it is real and rational. This one is real. It's rational. Is it an integer? Yes, it's an integer because it's a negative number that doesn't have a decimal or fraction. Is it whole? No, because it's negative. Right here I have negative 2.5. This is real and rational. Is it an integer? No, because it has a decimal. 0.5. An integer does not have parts. It's one piece. Okay? 2.5 has parts to it, 2.5. This is an integer. I mean, not an integer or whole. This number right here is real. It's rational. Is it an integer? No, because it has a decimal. And obviously, if it's not an integer, it cannot be whole. Now, the last part of your homework, and the third thing I wanted to teach you today, was how to tell which of those up there is greater. Now, if you have a calculator and you type in your calculator 1 divided by 3, you will get 0.3333. It goes forever. Well, that is the same as this, is it not? Therefore, they are equal. This homework tonight will be so easy if you will use your calculator. Now, here I have a negative and a positive. It doesn't matter what the numbers are. A positive is always bigger than a negative. So we're going to use our less than sign for negative 2. You could have negative 1 million. If the other number is positive, the positive number is bigger. Here I have 1.8 and 1.7 repeating. Well, this is like $1.80 or $1.77. Which would you rather have? $1.80. So the 1.8 is bigger. Okay. Right here I've got 6 divided by 8 and 0.75. Okay. Now some of you are saying, well, 0.75 is bigger. Others of you are saying 6 over 8 is bigger.
They're equal.
That's right. 6 divided by 8 is 0.75. Therefore, they are equal. Okay, so when you get a fraction, type it in your calculator, and it'll tell you what it is as a decimal.
How you know they
Now, so today we learned how to tell a rational number an integer, a whole number, okay, or a real number. We also learned how to make a decimal into a fraction, and we learned how to tell if a fraction is greater than, less than, or equal to another decimal.